Alright everybody, so welcome back to another video. So if you've been following along, you may have seen the first part of our build on our 2023 Transit fan conversion. So today, I'm going to call this the official start of the electrical and plumbing. But as you know, the electrical actually started a long time ago in the plumbing. When we were framing the vehicle, first started with the roof. You can see we already have all the lights installed. And that started with, pre-planning every step of the van, all the different components working together. From when we first did the floor, when we installed a light underneath the van to turn on from outside, which ran under the floor up into this wall, and is now one of these many wires that comes into the cabinet here by the door, to just running the ceiling light wires, running wires across the van, across the ceiling for communications and electrical. Built this wiring and pipe chase right here. That's going to be very important. So you've been following along. I show how I have cut holes for wires with a hole saw in the metal. Then I'm always using the nylon tubing to go around the wires, and then anywhere that they go through, like metal seams in the wall, will be spray foamed and caulked just to keep the wires from moving, keep any chafing from going on once the walls are installed. You can see that kind of before we put the ceiling up, I got all the wires ran across the top that needed to go through the roof, and then obviously we got all the wiring ran for the lights. You have to kind of do some pre-planning. It's good to draw it out on paper where all your switches are going to be, where you need to get power from. You see we've got wires that come down, wires that come through the roof for the solar, and then last but not least, battery to battery charging cables. Two 6-gauge wires. One's red, one's black, but they're both power feeds from the front. I'm using two Victron 30 amp battery to battery chargers. We're going to have a total of 460 amp hours of lithium iron phosphate batteries. Up in the front here, I ran off the 100 amp connection on the side of the seat with a 4-gauge wire to a terminal block here. It's just covered in electric tape just as a precaution, but it's not touching anything. And then two 6-gauge wires come off of it. There's also that smaller 16-gauge wire, which is a ignition feed wire, and that's going to tell the chargers to turn on when the ignition's on, or will prevent them from turning on when the ignition is not on. As I open the driver's door on the seat, you can see where I mounted our 80 amp circuit breaker inside of this nice little 3D printed case here. There'll be links in the description for all this stuff. So I have my 4-gauge wire coming from the 100 amp connection right here. Goes in. 100 amp connection is switched also. Basically it's on like a timer when you shut off the engine, and then it goes up in to the side of the van here, and then it kind of all culminates to the driver's side rear of the van. So as I've talked about in previous videos, we're going to have a refrigerator shoehorned right here, a microwave on top of it. And in this area here, I left myself quite a bit of room for a little bit of shower plumbing, city water inlet, and this is kind of like the junction center for the 12 volt and 120 volt wiring in the van. And what it's going to house is this box here. This is just with the cover removed. You can see there's a 30 amp breaker, double pole breaker here. This is going to be 120 volt, 30 amp service like most smaller RVs. And this whole side here is 120 volts. Basically what we do is we bring our power in. We use regular residential breakers in here. This is our neutral bus bar. This is our ground bus bar that we wire off of. There's a bunch of inlets and outlets on the back. There's even a dedicated outlet built into the back that you can use for something. I'm going to be using it to power a fan to keep the refrigerator area cool. Also have on this side, this is the 12 volt section. It takes standard automotive fuses. You can see it's got like a large, I believe it's 6-gauge cable. Neutral, this is where you wire all your negative, not neutral, all your negatives for your 12 volt. And this is your input for your negative. And this is our input for our positive side. We have everything fused, and these are our outputs. With this box here, which I'll put a link in the description to, it's relatively inexpensive, and this gives us 15 DC outputs. This does support up to 30 amps. If you're going to run something like a 12 volt air conditioner, something that draws more than 30 amps, you would run directly off of whatever system you're using in the back. There will be battery terminal junction block back there. You could have a separate fused or circuit breaker on that line. This is for all of like our power points and our lighting and fan and all that type of stuff. What's nice about it, you can see I've kind of pre-planned the area here. This will just fit in here like this. The cover will fit on, and unlike my prior build where I had everything kind of stuck in the basement, you can kind of get to everything from right here, which is nice. In the van, you have access to all your power. You can shut, the refrigerator off, anything you need to do from right here. Then right across the road, we have not built the rest of the cabinet over this yet. You can see this is our water heater. So I ended up using this exact same water heater in our ProMaster van conversion after I started with the electric Bosch water heater that a lot of people use. And the reason I switched to this Kuma water heater is because it has 2 ways to heat the water, and it truly does make a much more capable off-grid vehicle. So out of your van conversion. So basically you can run it off of 120 volt AC power, pulls about 1500 watts, like most electric, 120 volt water heaters would. And, so if you're on shore power or you have a lot of battery, you got good solar days, you can heat the water. You can put it on a timer. There's a bunch of stuff you can do. It does have a thermostat, obviously. Once it heats the water up, it'll shut off. I'm going to be, on my first van conversion, I used a timer switch, and I think the max time that you could have this on was 60 minutes, and that was plenty of time to heat up all the water. I think it's like 6 or 7 gallons. Yeah, this is 6 gallons. Or the best part about this is right here. These are coolant lines to run to the engine on the van. So when you drive the van or idle the van, hot coolant runs from the engine under the van. There's going to be a hole coming up through the floor. Hot coolant will circulate through the tank, and it will heat your water. So instead of just wasting engine heat, if you're driving down the road, when we've been camping, we needed hot water. I started the van for half an hour, let it get up to operating temperature, heated all 6 gallons of water nicely. 2 of us took a nice, quick shower in comfort just for running the van for about a half hour. So if you have a situation where you don't have a lot of power, that gives you another option. It's very nice. The main reason that I really like this water heater over something like the Bosch or any of the other electrics is right here. This is a drain port on the water heater. So if you're doing any, if you're not living in the van and you're not keeping it constantly heated, obviously in the winter you need to winterize. The only way to winterize that Bosch water heater is to completely take out the water heater and turn it upside down to dump the water out. There's no way to drain the water out of it, and if it freezes, it will break the water heater. This one is also completely aluminum. You don't have to worry about corrosion issues with a steel tank. And I take that back. That's the outlet right there. Normally it comes with a little hose valve. I'm going to be putting a different outlet that you'll see on that line there. So it's really simple. Cold water in, hot water out, coolant lines, electric, which is going to be plugged in to an outlet here. This will have its own 20 amp breaker on the system. Alright, so I talked about this a little bit in the last video, but routing of drain lines. So we're going to have it's about a 16 or 20 gallon gray water tank that's mounted next to the gas tank, this area of the van up here. The shower drain obviously goes right down on this side, of the right side of the shower. It'll go into a HEPVO sanitary valve under there before it goes in the shower. The sink is going to go down. It's going to run through a similar type of one-way valve here. That way, you know, gases and smells can't come back up this way. It will run down. It will come through this hole here, come down, go under here, and there'll be a slight angle the whole time to maintain water flow. It will run through the pipe chase. You can see I've already taken a drill. I put a hole through the floor to make sure it was in a good spot with a small bit right basically in the center of the wheel well on the inside of the wheel. That will come down. You'll take an immediate turn and head over to the gray water tank. So there's a few different ways to do that. If you want to run the water lines from this side, the sewer or the gray water line, this side of the van to this side of the van, the gas tank is really in the way. You would have to come down and go all the way around the front or the back of the gas tank. Also, if you do any cold weather camping, your water pipe could freeze. It's kind of unlikely, but it could freeze. I will have a tank heater, just FYI. You'll see how I do that. But so this keeps everything inside of the warm space of the van. Some people build it into the floor, incorporate it into the floor. Again, like I said, always got to be thinking your overall design first. If you can't go back later and try to add it under the floor, that's a nice, easy way to get it straight across if you have the room to do that in your floor installation. It still could be kind of cold on the pipe, but you know, that works. This is going to work for me, just doing it like this. Some people actually put a separate gray tank on this side. Some people just let their sink drain into a, you know, some kind of collection under here and then dump it out. There's a bunch of different ways to do it. I guess the most important thing is just plan it out ahead of time. That way you don't get yourself trapped and then you don't know what to do. So again, I'm going to take this. I'm using 3/4 inch pipe. I thought it was 1 inch, it's 3/4. It'll be plenty big for sink water though. And I'm using this 1 1/8 bit here. And I'm going to put a nice little hole. It'll be like the 80th hole I've drilled in the van, so start to get used to it. We'll get the pipe down through there. I'll just have it extend down a little bit for now until I'm ready to work on the gray tank underneath. We'll seal it up with some sealant, some expanding foam, and we'll get this kind of plumbed in first. Take it like a layer at a time. So I'm gonna dig my floor and the wood out. And like I always do, I will go under the van and put a little bit of, I use a cold galvanizing spray. But it's basically just to keep it from rusting. So I got that pipe done. Runs over. So there's a constant slope towards the exit to where even if the van was kind of cockeyed, it would still be sloping. So I just need to make that connection from there to there. All right, so got that's going to be the outlet for the water heater. That one next to it's for the stove, so on a separate circuit. And that outlet is basically switched from up here to turn the water heater on and off. So moving back here real quick, so I got this board. This is going to be what all of the electronics mount on. It's just a piece of 1/2 inch sanded plywood that's been painted black. This area will be all kind of contained back here, but starting by just mounting everything. So you'll see exactly what goes on to it. See, there's a ton of wiring that comes back here. And the reason why is there's a lot of this 10-3 wire. So the shore power comes in here from outside. And I'll show you how I installed that and the city water inlet. Alright, so we're using this Victron 30 amp, 120 volt connection. Uses the twist lock, screw down, like marine style connection on the side of the van. And then on the other end it plugs into a standard 30 amp RV outlet. For that connection we're using this marine grade 10-3 triplex wire right here. So it's obviously hot, neutral, and ground. And we're using 10 gauge because it's 30 amps. If you're only 20 amps, you could use a 12 gauge wire. And then while I'm drilling holes, like I said, I'm going to be doing the city water inlet here on the side of the van. So I'm doing all 1/2 inch expansion PEX pipe. So this is an expansion fitting right here. And it's just got a 1/2 inch thread. So I'll get that threaded on. Now, if you don't understand how the water system works, this right here is a one-way valve, so water can only come in and can't go out. That way, when you're pressurized with your pump, when you're using water out of the tank, it doesn't leak out of this. And there's also a check valve like this before the pump, so when you're on city water, it's not back feeding through the pump into your tank. Alright, so I'm just going to put this little extension on here, give you an idea if you've never seen how expansion fittings work. Basically just cut your pipe to length. Let me put this little collar over it. It's got a little stop. And you use one of these expansion tools. Basically it just expands this, and you stick it on and it will shrink back down and becomes very tight. I'm going to work kind of fast, bottom it out. Then it will start shrinking. We'll just hold it here. See, now we can't pull it off. Well, the one nice thing is you still can kind of rotate them though. So when you're doing fittings, if something needs rotated or adjusted, there is that ability. Alright, so from the inside I made a pilot hole. That's for the water line. And then same line. That's for the electric input, shore power input. So I'm going to go ahead and drill this now. Using a 2 3/8 metal hole saw. Now once you drill that, you want to clean up that, get any metal shavings off, blow it all off, otherwise it'll turn to rust just like any penetration. And then I'm going to put a little bit of paint over this right here just to help prevent it from rusting even though it's going to be sealed. That's perfect, 2 3/8. Then how this works is, obviously this unscrews, we'll pass our wire through it to strain relief. Foam gasket comes off. So this clips on there, just turn it like this, pull it off, and then we can tighten down the screws. It's black, white, and green. I got it all labeled for you. And then you forget to put the gasket in between. You have to take it all apart again. Alright, so try this again. Go slow with these, not strip them out. Make sure that gasket's nice and compressed. Alright, so it's kind of the same thing for this hole, pre-drilled, some mounting holes, except I'm using this butyl rubber on this fixture. So just stick it through. The screws kind of lined up. Until we see the butyl rubber kind of squish out. You don't want to strip the screws again. So now that you've seen that, so we have our inlet and we have a bunch of wires, and what's going to happen is there's going to be a manual transfer switch right here. So normally what happens with the setup I'm using, the Ames inverter, is your shore power comes in, it goes into the inverter. The inverter is a transfer switch. The inverter can, as long as it's on, will run off of shore power as long as the shore power is a good connection. If it's not, it'll transfer to battery power. If you unplug it, it's like a UPS system. It immediately, without blinking, goes to battery inverter power. It's pretty nice. So the inverter's gonna be mounted up here. This is inverter in, inverter out. But like I said, I'm putting a manual switch. So basically, if the inverter were to ever, it's just a fail-safe. If the inverter were to ever not work, or we want to bypass the inverter on shore power, you can just switch it to where it will not run through the inverter. The shore power will come directly in and then go to the panel over here. I've got one 6-gauge wire here that's going to run down. So since my battery-to-battery chargers are what's called non-isolated, which means they share a common ground with the vehicle system, you have this nice ground point for the vehicle back here. So I'm running this one 6-gauge wire with a crimped on terminal on the end. It's going to connect to the factory ground point. This will run back here. It'll come out through here. And this will be the ground, and this will go to just the ground bus bar. And then I can feed a common ground off the bus bar into both of the battery-to-battery chargers, and obviously it will connect to our batteries, and then it will connect back into our power distribution system. So it's a good idea to draw out how your whole system is going to look. So you could basically, if you're going to do something like this with like a board, draw it all out where everything fits. So in my case, if you can imagine, so the inverter will be here, the battery to battery and solar will be over here. Now I do have my hot line from the solar coming in over here because it's going to be running through a circuit breaker connection first. That way I can shut the solar in off, and then it will also come out of the solar and through that same system. Basically, I want to be able to turn everything that's important on or off from the back of the van here. So I'm going to be using a separate circuit panel that's mounted on the outside of this whole setup. So if I open the back door, I can switch on and off my battery to battery chargers, my solar, anything that I need to easily from back there without having to climb into the back of the van. All right, so here's the final, all the wiring before I start hooking stuff up. There's a ton of it. And then last but not least, we're gonna have our, it's gonna be 8-gauge from a fused or circuit breaker coming off the bus bars that will go over to our DC distribution panel input in here. All right, so I finally got all the wires run here. Now I'm ready to start actually attaching the inverter and charge controllers and stuff to the board here. So this is firmly secured to the wall. See, there is a ton of connections. Now, you could make a lot of these connections on the outside. So a lot of these wires just literally run from here to here. But it's just gonna look a lot tidier once everything's installed to have all this going behind the wall. Even like these AC wires, they'll just run over here. All right, so I got the inverter bolted to the wall. You see up here, these 3 bolts, those go through the wood and into the sheet metal of the van. So this thing's really on there well. Here's my distribution. These are 3/8 lug bus bars, positive and negative. So if you're using a Victron, a whole Victron setup, this would be like your links distributor. These are a lot cheaper. They do the exact same thing. Obviously there's no monitoring on this, but we'll have a shunt. So now that I have my wires run into here, I'm gonna go ahead and start wiring up this panel here. That's gonna take a while. Basically what I'm doing is I'm bringing my 120 volt 30 amp run or AC into here, and they have this split, so if you have a camper that you want to put 240 in, you know, split phase, you could do that by running the 2 lines here. Then you'd have a few breakers each direction on each leg. Since this is single phase and just 120 volts, what I'm gonna do is I'm gonna have the input coming in, and it's going to go into one side, and then it's just going to be jumpered to the other. That way this is all just energized off the same leg. We'll wire our neutral line coming in into this bar here, and you see our green wire back here. This will be for our ground bar, and then all of our circuits that will go out through these holes here in the back, and they will come in and wire to their respective breakers, neutral and ground. Pretty easy. Like I said, this thing here that they include is just for that outlet that's on the back of it. You don't have to use it, but if you have something to plug into it like I do, it'll be wired to the refrigerator circuit. And then same thing, we'll have to knock out these cutouts so we can get all of our 12 volt wiring in, and it will run through these holes here into the back. So there is that all wired up. Surprisingly, I took up every single breaker slot. So we've got fridge, 20 amp, microwave, air conditioner. This is the main breaker. This is our driver's side, passenger side outlets, and this one will be the water heater. And then, so I've got all my neutrals, all my grounds in the back, and then over here got all the 12 volt stuff. This right here is going to be for the heater. I have a little bit more wiring to do on that, but kind of a mess in here. Get this tidied up just a little bit. And then the only other thing I need to do in here before I can close this up is I'm going to put a little fan here. That way when the refrigerator is on, this fan is pulling, just a little computer fan's pulling air out of this area, and the vent's gonna get relocated over here, so it'll blow the heater air under the back side here. And then I have to get the plumbing done. So you can see I've got the holes drilled for the shower, so I'll get that put in. All right, so as I mentioned, so I've got my inverter installed. I've also got to get 2 non-isolated DC to DC chargers put up, and a solar charger, and we have to get the shunt installed for the battery monitoring system. Then there's going to be a power disconnect. So what I got going on here, so this is our main input. It's shore power, I should say. Comes into this box here. There's just a single 30 amp breaker, as you can see. And then that feeds 2 things. Out of this box, our power goes to the input of the inverter, and it also goes to the switch right here. So with the switches in the 0 or off position, no power is flowing through the system. Well, I should say power is flowing to the inverter, but if the inverter is off, there's nothing happening. If I switch the switch over to 1, that is called a shore power bypass. So what happens is, if there's something wrong with the inverter and the transfer switch isn't working and it's not passing shore power, I can just switch it to 1 and we can still have power, whether it's from a generator or plugged in or whatever. If I switch it to 2, this will be the mode that it's normally in, where it's allowing the inverter to control the shore power. So it's acting as a transfer switch, a battery charger, etc. This is just in case there's ever anything wrong with this. There will be a whole separate video on how I wired this, because it's not a little tricky. You just have to know what to do. It's not just plug and play. So there'll be a link in the description for exactly how I wired this switch. Alright, I'm working on making the battery cables now. I'm using these tinned copper lugs. They're 3/8. I'm using 2/0 cable, which means 2/0. There's a difference between 2 gauge and 2/0. Basically, it starts at like 18, 20 gauge, and the lower the number, the bigger the cable, and then it starts working its way back up once you get to 0. All right, so I'm right on the border of 2/0 and 4/0 cable. There's quite a big price difference, but I've got this 2500 watt inverter, 2500 watts. Your 2/0 is going to be about at maxed out. If you step up to a 3000 watt inverter, I would go ahead and step up to the 4/0 cable. Like I said though, it'll be fine for everything I'm doing. Again, this is 2500 max watts that I would ever pull, so not really worried about that. But basically, I have this hydraulic crimper. For years I've used a hammer crimper. The problem with that is you have to make all your cables out on the concrete where you can smack this. This one you can kind of make them in place, which is really nice. It's not that expensive. You just pump this cylinder here and put different size dies in it. I am using the 1/0 die on the 2/0 cable just because I want a little bit tighter of a crimp. These are pretty important, that these are crimped good. So I'm just using one size smaller than what it says to use. You could also crimp and solder. You never want to just solder these. You have to have a mechanical crimp on these cables, and you need something really strong like this. So I'll put a link for the description in this one. In here. And that's it. There's the crimp. The last step is take some heat shrink, go in there. Heat it up. And that is our completed cable, and that's how you do it. So made a lot of progress, got the batteries in place, got all the charge controllers wired in. So the basic premise is obviously solar on the roof, comes down through one of these wires here, comes into a circuit breaker here. So we'll say this one right here, solar in, comes in, then it goes out from here. So basically I have this row of breakers here so I can quickly turn stuff on and off from the back of the van. I don't have to crawl up into the basement to do anything. Same thing, main battery disconnect switch right here, real easy to get to. So solar in, then it goes from there, goes over to the charge controller, comes out of the charge controller, comes all the way back over here. This is the solar out, so I can isolate solar in and out. and then that goes back and goes on to the bus. So basically the red bus bar there, 3/8 lugs. Below it, kind of hard to see, it's all the negative bus bar. Okay, that's where everything ties in. Same thing, the battery to battery chargers, I have two 30 amp Victron battery to battery chargers. That has a circuit breaker up at the driver's seat, which you've seen. So then it comes in to the charger there. So that's how you cut off, the input is up there. And then there's an output from both battery to batteries. Comes through here, you can flip that on and off. Basically you're either shutting both of them off with this double pole breaker, or you're shutting them on. Now if I do want to just have 30 amps of charging coming off the battery, like let's say I don't want to use both of them, that's where these control wires come in here. So I ran a separate control wire, and this goes to the battery to battery, the Victron converter, and I have these switches right here that are backlit. So basically this will be battery to battery 1, this will be battery to battery 2. I can turn them both off right here at the control, or I can have just one on, or I can have both of them on from back here. So since they have a control, it's just a 12-volt control, which is also runs from the ignition feed up under the seat. There is an ignition wire. So if I turn off the ignition, it shuts off the battery to battery chargers, and then I can also override and turn them both off right here, if that makes sense. So everything will be neatly under this cover back here, with this, which is weatherproof. It's inside the van, but it's still weatherproof. And same thing with the master disconnect here. Unfortunately, I have all the lugs I needed except one 3/8 lug that I need to complete this last cable that goes from here to here. So the two batteries are in parallel. I got that cable made, it's laying on the ground right there. But I just need this one last wire here. And then the electrical system will be complete. As you can see, there's how the wires go in and out on that. And there's the wires wired in and out of the inverter, 10 gauge. There's my batteries. The lead time, 230 amp hour each. So I have a total of 460 amp hours. So almost 500 amp hours in this really tiny little compact space here. What's great about these batteries, they're new. They do have low temperature protection. So they will stop charging automatically if it gets too cold, which is great because I don't have to worry about using any kind of temperature probes. I would have to have low temperature protection on the MPPT charger. This you can plug in low temperature protection, but again, I don't have to worry about any of that because unfortunately the Orion Tri-Smart battery to battery chargers don't support that. So would have had to come up with something anyway. The batteries are going to handle that themselves. Alright, so this is what it looks like, the cover installed here. You can see I got the van running, so if I turn those on like that. Alright, so I've got everything labeled. I've got a few fuses in, so the heater and everything is now running off battery power. I just got the lighting all wired in. So basically I have one 15 amp feed that comes in to this whole switch area here. Then the interior lights in the van are on a switch with a dimmer. And then this is the outside lights. So if I turn on the first switch, it turns on the overhead light there. Second switch, under the van. And the third switch, the awning lights. Alright, so back on the plumbing a bit. So needed to drill a hole through the floor. So I drilled a 2.5 inch hole all the way down through the insulation and through the sheet metal. And as always, I put like a cold galvanizing spray paint basically on the metal from below. Then I'll take this, it's just a 2-inch coupling and a little section of 2-inch pipe, and I'll put silicone on it. It'll go down and be glued in the hole like this. This will basically make the pass-through for my coolant lines that run to and from the engine, and then we'll have our dump valve, you know, to empty the water tank in the winter, to winterize it, and the emergency blowout valve will all go through. So there'll be 4 smaller lines going through this hole in the floor right here, and then we'll fill it up with some foam after we get all the lines run through. All right, so this might be one of the most important things I talk about when it comes to building out your van. So I'm in the middle of the wiring up all the electrical. You saw that, and I was not happy with the Ames inverter and its performance. So I've used one in the past. I had good luck with how it worked. This time I went with the green version, as you saw, which was 2500 watt inverter. On paper, everything I needed. So the first thing I noticed when I first turned it on was the hum, which is normal for an inverter. There's a big transformer in there, it's going to hum. It was louder than the last one I had, which kind of annoyed me because you would hear it just running in the van. And then I noticed, I mean, everything seemed to be working okay until I noticed the first time it got done with the charging cycle, and I was just standing here in the van in the evening, and it went into float, and all the lights in the van were flickering. So I immediately thought, maybe I wired something wrong. Maybe there's a poor ground or something. No, that wasn't the issue. If I put some load on the inverter, it would stop. If I turn the charger on the inverter off, it would stop. And I was watching it on a voltmeter, a sensitive voltmeter, and the inverter was actually raising and lowering the voltage. It was defective. And then this is the important part. I reached out to the manufacturer, Ames, put in a trouble ticket. I was outside of the return window from where I bought it, and they never got back to me. So I'm just gonna say that's just my experience. For just a little bit more money, I went ahead and just bought this Victron Multi Plus 3000, which, I mean, if you see the rest of the stuff in this system, why didn't you do that in the first place? Well, like I said, I've used the Ames one before. It kind of comes a little more ready to run than one of these Victron units. To make one of these Victron units work, you gotta buy a control. You gotta decide if you want to go with like a Servo GX, which adds another $500, you know, for the minimum amount of control. In my case, I'm gonna use something a little simpler. I'll show you that in a minute. And then there's programming that's required for one of these that you have to do out of the box to make it work right. It will run out of the box, but not the way I want it to. With that said, the Victron is a much better unit. It has a lot more options. It can do a lot more things. And one of the coolest things that it can do is it can control the amount of power it takes off of shore. So if you are camping, I'll just touch on this quick because there's a lot of videos out there about this, but if you're camping somewhere, I like to say it, you know, you go to a relative's house, you're camping in their driveway. You're going to plug in shore power. The level of power that you can get when you're at someone's house like that, run an extension cord, varies greatly. So if you're trying to run an air conditioner or something like that, we've blown circuits at, you know, relatives' houses before, camping in their driveway, because maybe they have a refrigerator or something on that circuit. And after all, we're using the 30 amp connection. Nobody has really a 30 amp RV connection at their house. So with this unit, you can dial it down. Let's say you want to be safe and you only want to pull a maximum of 10 watts off their house. What this unit can do is right on the control, you can dial it down to how much current you want to limit it to. It will use the batteries, like if you're running your air conditioner, and when it starts the motor on the generator or the compressor, it will temporarily switch to inverter, give it the power it needs, and then ramp right back and switch back over to shore. and just run it off at a lower voltage. So kind of a neat feature. I expect that this is going to work a lot better for me. Problem now is though, everything was made to fit that Ames inverter. That's one thing I liked about it, was it had a nice slim profile. So now, luckily, I left a little bit of length on my AC cords. Hopefully they will reach in here because we need a lot more room to get stuff in. As far as battery cables, everything comes in the same side on the Victron, so I'm just going to shorten those up, and I should be able to make that work fine. And there is, I did measure before I ordered it, just enough space. Now, as far as this being a 3000 VA, it's volt amps. Victron rates their stuff different. That works out to about 2400 watts. So this is comparable to the Ames inverter that I had as far as specs. Again, about $300 more, but probably will be well worth it in the end. You don't really want to cut corners. Don't be cheap. You're spending the money one time. You want to do it right, and buy it probably from someplace that you know you can talk to someone and return it if you have a problem. Now, I got lucky. The Amazon seller, Trends Auto, that I bought it from, even though it's outside the return period, they said they would take it back. They would either do an exchange or a refund. They didn't have another one in stock to send me, so they're going to do a refund. So kudos to them for doing the right thing and standing behind the product they're selling. All right, so I'm going to get this put on the wall. You have to take the whole cover off. The way I'm going to mount it, I'm going to mount it horizontally. Normally you would mount this vertically, but it does say in the manual you can mount it horizontally or vertically. I just have to take the cover off to get to the mounting screw holes. Okay, that's a little more like it. So it looks like might just have enough room to get those in there, get them connected. All right, so obviously I'd already made my hole for the Ames inverter controller that was right here, which kind of stinks because this is the multi-control that I'm using for the Victron one here. You can see that it is a lot smaller than the hole that was there. So what I did was I made this plate out of this ABS, this 1/8 inch thick ABS plastic, to kind of adapt the hole size. So let's see, it won't look bad. It'll look like it was supposed to be that way, hopefully. But the good thing is it uses the same, just uses an RJ45. Basically it's a network cable. So it uses the same cable. So I'll go ahead and plug this in. Again, you can use a Servo GX with the color screen, but you don't really need that unless you really want to see everything that's going on. I can tell what's going on with the system. The battery monitor, I'm also going to have Bluetooth. If I really want to see what's going on, I can just use my phone or tablet or anything and Bluetooth in to the system and see what's happening. Or even on the head unit, the Android head unit that we have in this vehicle, it'll have the Victron app running on it all the time. So this one's real simple. It's off, charger only, or on. So you can have the inverter so it's just charging the batteries and not inverting. And then this is the current limit dial. Okay, so have the new inverter all wired in. And now I'm going to be downloading the Victron Connect Windows app, and then I need to use this MK3 VE bus interface. So you plug one end into the LAN cable port, the RJ45 connection on here. And the other end, you can see it's got a USB cable after we get the software installed. And then I also have the VE smart dongle here. Basically it comes with a battery cable. I will connect it to the spare positive and negative terminal in there. And this then plugs into one of those interface ports. Once we're done with this, we'll plug this in. And this will let me control some functions of the inverter and do some changes via Bluetooth on my phone, just like you can do with the solar charge controller and the Orion Tri-Smart converters. You just can't do like firmware updates and some of the settings that we need. So this will be, the smart dongle will be connected permanently. This is just going to be connected temporarily to program it. Alright, so now I'm connected via USB. Go to settings. Alright, if it gives you a password, it's ZZZ. Alright, so there's two of these VE bus ports. So one of them is connected to the cable that runs up to the front to the control, and then I have this little one here. This is just standard Ethernet cable, so I'll plug it into the other one, and then the other end will be plugged into this Bluetooth module. And then I just need to connect the battery cables to those secondary terminals. It does come with a fused wire lead there, so I'll just pop that out. And this has double-sided tape on the back, so I can stick it to the inside of this cover. Everything will be contained right inside of there. Alright, now I got the cover on. Open up the Victron Connect app. You can see this is VE Smart Bus. So that is our inverter. Alright, so this is a mandatory firmware update for the VE bus, so update that. Alright, firmware's been updated. Click on it here. Alright, there we go. So now it's showing us our inverter. So it shows the AC input, and it's limited to 15 amps by my switch up front right now. Battery voltage 14.4. And the absorption charge 65 degrees Fahrenheit. If you click detailed, it'll just give us frequency. And so you can create a VE smart network. So I can do that with my MPPT solar charger. So now the two units are communicating with each other, so they won't basically charge over each other. And it says that it is transmitting battery voltage and temperature sense to the solar charge controller. Alright, now when the van's running, obviously my two battery chargers will be on here, then my solar and my inverter. Alright, so that's all there is to that. Everything is set up and running properly. This is a much better choice. I think I'll be really happy with it. It's nice and quiet. Lights aren't flickering. Everything's good. Alright, so working on the water tank now. You can see we've got our line that comes from the pump back to here. Comes out of the tank. We'll have a shut off right here. And then over here, this tank has another outlet on the bottom, which we're going to use as our drain. So to make the drain, same thing, drill a hole through the floor. I take this little stainless wire and a hose clamp. And that keeps, you know, like mud daubers or anything like that from trying to get in the pipe and block it up. And then we'll stick this up from the bottom and make the connection. Drill a hole through to the ground. Alright, so there's how that looks. Then there's how it looks up the bottom. Also, the other day, didn't get on a video, but pressure tested the plumbing that hooked up to city water, bypassed the water heater. So again, if I didn't really explain it too well, everything's covered in dust. You know, like right now it's in bypass, so it's off and it's off, in and out of the water heater, and then this middle hose is on. So basically when the cold water comes into the system, it just bypasses the water heater because I didn't want to fill it up. Yeah, the plumbing, I just have a few little things to do, like install the sink, but you can see I've got my PEX lines with shutoffs running here, the drain pipes there. It's going to be terminated into the sink. And then the 2 PEX lines for the outdoor shower there. So basically it's all the rough plumbing is done. The main thing I want to do is test for water leaks before we put the fridge in. Alright, so I've got most of the outlets and switches and everything roughed in. Everything works as I've been slowly installing stuff and bringing it online. When we're done with the project, obviously I'm going to have a video that kind of details all the features and all the electric stuff, but you know, like I showed, everything's labeled, and I've been slowly adding fuses as I get stuff working. There's still a little bit left to do, but the bulk of all the electrical is done and everything is working. So hopefully the video was a little bit helpful if you're in this process. I will say it's kind of tedious, and like I said from the beginning, if you go way back to the very first video we did on the van build when we were doing the floor, you have to have a plan from the beginning for the wiring, because all the wiring runs through the roof, runs through the walls, it goes everywhere. As always, really appreciate your support watching the video. If you have any questions or comments, leave them in the comments section. Try to do my best to answer them. I'll have links in the description for a lot of electrical components that I used, because I know it's helpful sometimes to have a place to start. So be sure to subscribe. There's lots more coming with this build. Thanks for watching. Till next time, we'll see you later.